Okay, so back to scheduling. Let's say that this is our new objective. So I introduced completion times. We know a little bit about our jobs. Let's say we're trying to minimize the weighted sum of completion times. So this is our minimization criteria. And I'll just leave this up here for a few seconds for you to look at. Okay, so the cost of a schedule is going to be equal to the sum of the priority times the completion time of all jobs, and what we want is the minimum of all such possible schedules. So one schedule could be scheduling things in order, another could be, I don't know, in reverse order. Let's just say there were 3 jobs, or we could do them in sort of any other order. And we want the schedule that gives us the minimum sum of completion time, so the minimum of that equation. Let's just start by saying, well, what is the completion jobs, or the completion time? What is the weighted sum of completion time? So this equation up there. If we schedule these jobs, so jobs 1, 2, and 3, in order. Okay, well, we have these 3 jobs, and I'm going to have a few diagrams here, and what we're going to see is that the width of a job is going to be indicate the duration. The height of a job is going to indicate the priority. So if you notice from the previous slide, we had job 1, which would have been a 1 by 3, so it should be skinny but tall, which is why we got this for job 1. Okay, so this is the schedule that we had for jobs 1, 2, and 3 according to the previous slide. And this would be a great place to pause the video and work through exercise questions 1, 2, and 3, and then we'll get to those as we when you come back and you rejoin the video. Okay, well, when I schedule these jobs in order, that means I have to compute the completion time of each of these jobs. So job 1 will have a completion time of 1. Job 2 will have a completion time of 1 plus 2. And job 3 will have a completion time of 1 plus 2 plus 3. And then their weights, their weighted sum that contributes to the weighted sum of completion times is just this priority row times the completion row. So we'll have 3 here, and we'll have 2 times 3 is 6 here, and we'll have 3 times 1 is 3 here. So our total here, and I don't know how I did that, but I can't multiply, or add, I guess. This is equal to 6, not 3. So we're going to have 6 plus 3 is 15. So the more interesting aspect here is not sort of giving you the weighted sum of completion times or being able to compute that. It's how do you create a greedy algorithm for optimizing our schedule. So our general process for coming up with a greedy algorithm is to just look at some special cases of the problem, just to give you an idea of can I solve this simply or not. Describe some possible criteria, compare the criteria, select the best one, and then prove correctness if possible. So these are the steps we will go through throughout the rest of these slides for this greedy scheduling problem. So this is our goal, again, to devise a greedy algorithm to minimize the weighted sum of completion times. And why are we approaching this with the greedy algorithm? It's actually pretty easy. You'll see that what we come up with is both efficient and easy and also optimal. And so if you compare this to the process you would have to use to come up with a divide and conquer algorithm, I think you'll agree that this is just for a more straightforward process. So okay, part 1, step 1. What are some special cases to consider? So let me give you some special cases here. We have jobs, and jobs have a priority and a duration. Well, a special case might be if they have equal duration. So for example, this is P1, D1, and P2, D2. And let's just say that D1 is equal to D2. So equal duration. That's one special case. So that means that they have different priorities. One of them is a higher priority and one of them is a lower priority. And I'll denote that with PH and PL. So the first question that we should look at here as a special case is, should we schedule the lower or higher priority job first? So let's just dig through this and go through both versions. Let's say we schedule the higher priority job second. Our weighted sum of completion times, so let's call that the weighted sum of completion times, is equal to the duration of the first job, which we'll call DL, times the priority of the first job, which is PL, plus the duration of the second job, or sorry, the completion time of the second job. So it just so happens that the completion time of the first job is always just equal to its duration. Well, the completion time of the second job is DL plus DH. And we're going to multiply that by PH. So that's our weighted sum of completion times for this particular schedule. How about when we swap the order of these two jobs? Our weighted sum of completion times is now going to be the duration of the higher priority job times the priority plus that. So which one of those is a better scenario? So we have two, the schedule with the lower priority job first, and for that we had DL times PL plus DL plus DH times PH. And we want to know, is that, how does that compare to our schedule with the higher priority job first? So for that we just, switch the order. So we've got DH times PH plus DH plus DL times PL. Well, let's distribute this through. So over on the right hand side we have DL PL plus DL PH plus DH PH. My handwriting is getting worse, I can tell. And again, we're still trying to figure out which one is the better of these two sides. As you can see, I can cross some terms out here, so I have a DL-PL on both sides, and I have a DH-PH on both sides. So really what this comes down to is what's bigger out of these two, DL-PH versus DH-PL. Well, if you recall, we said that their durations were the same. So for this special case, we were saying durations are the same, which means that DL is equal to DH, and we can cross those two out. We also know that PH is greater than PL. So which one of these schedules is better? This schedule or this schedule? Well, if you recall, we're trying to minimize here, so we want the lesser of the two, which means our better schedule is this one. It's better to schedule the higher priority job first and get it done with, as opposed to having this higher weight be multiplied by a higher completion time. All right, so we can go through the same process. So this is our summary for this one. If you have two jobs equal duration, schedule the higher priority job first.